All right, so 14.1 is graphing trig functions. Okay, so if you look at the unit circle, let's talk about let's talk about the function y equals sine of x. Okay, so let's just kind of make a t-chart and graph this and look what it looks like. Okay, so what's the first thing we know the sine of? And let's say it's in degrees this time. So 0 degrees. What is the sine of 0 degrees? 0. Okay, it's on the unit circle. 0 is right here, and it's cosine sine, so sine 0. Okay, the next angle we know the sine of is 30 degrees, right? And sine of 30 degrees is 1/2. I'll put it as 0.5. The next thing we know the sine of is 45 degrees, right? 45, what's the sine of 45? Square root of 2 over 2, which for graphing purposes, how can you graph square root of 2 over 2? Look, the decimal approximation is 0.7. Okay, the next thing we know the sine of is 60 degrees. What's sine of 60? Square root of 3 over 2, which that's hard to graph. I'll tell you the decimal approximation is 0.9. Then the next thing we know is sine of 90. Right? Sine of 90 is what? 1. Okay? So, then let's look at, what's the next one we know? Well, after 90, we know 120. What's sine of 120? Nope. Square root of 3 over 2, which is 0.7, right? Next is 135. What's it? Square root of 2 over 2, which is this was 0.9. This is 0.7. Okay, then we've got 150. What's its sign? 1/2. And then we got 180. What's its sign? 0. Okay. Then after 180, we've got 210. What's sine of 210? Negative 1/2. Okay. Then we've got 225. Now you're not going to do this every time. I'm going to show you where the pattern comes from, and then I'm just going to show you how to find the pattern. Okay? Negative square root of 2 over 2, which is negative 0.7. Then we've got 240. Negative square root of 3 over 2, which is negative 0.9. Then we got 270, which is right here. Negative 1. Okay. Then round out the last quadrant. So then we've got 300. What's sine of 300? Negative square root of 3 over 2, which is negative 0.9. Then we've got 315. What's sine of 315? Which is negative 0.7. Then we've got 330. What's that? Sine of 330? Negative 1/2. Then we've got 360. What's sine of 360? That's the same as 0, so it's 0. Okay? So let's plot this on a graph and see what it looks like. Okay, so we're going to plot all of these coordinates. 0, 0, 30, 1/2, 45.7. Yes. Yes. Okay, so here we go. So let's say this is 360. So that means this would be 180. So this would be 90. This would be 270. So this would be 45, 135, 225, and 315. Okay. And we'll make this be 1 and this be -1. Okay, so the first point we're going to graph is 0, 0. Right? Then we've got 30, which is like right here, 1/2. So like right there, right? Then we've got 45.7. So like right there. Then we've got 60 is 0.9. And 90 is 1. Okay, so you see a pattern? Okay, then we've got 120 is 0.9. 135 is 0.7. 150 is 1/2, and 180 is 0. Okay. 210 is -1/2. 225 is -0.7. 240 is -0.9. Let's make this -1. And 270 is -1. And if you finish it out, it does that. Now what's going to happen if we go 390? It's going to be just the same as 30 here, right? So it's just going to keep going in both directions. Okay? Now this graph, it repeats itself, so it's called periodic. What is the period of this function?
180. Me 360.
Right? So the period is 360 degrees, because if you chopped it off right there, that's what repeats over and over, right? Can't say 180, because that would just be this repeating over and over. You got to have this part too. All right, and then the other thing is the amplitude. Well, the amplitude is, you draw the midline, and it's how far above or below the midline you go. So what's the farthest away you ever are from this line? Or here, right? But the distance is 1 in both cases.
Would there ever be
Yep, we're getting there.
would you have like 2 answers if they different?
No. Well, no, it'll never be where these are different. No.
Oh, this
No.
What if, like,
You always have to go up and down the same amount.
What if the period was like this?
We'll get there. It would have been, yeah, we could have done that. If you'd gone from 90 to 450, that would have been the period. And you could have kept your period. But either way, it would have been 360. It would have been 360 wide.
Oh, okay.
So no matter where you count it, you're going to get 360. Okay? So notice some things about sine. Where does it start? It starts at the origin, right?
Mm-hmm.
Starts at origin, and it's increasing at that point. So when I graph sine, I say it goes middle, top, middle, bottom, middle, top, middle, bottom. Okay? Now cosine is going to be a little different. Well, before I do that, what if you had to graph y equals 3 sine of theta? Right, it would be the same thing, except every time once we got the y, we would multiply it by 3. So what would happen is you would start at 0, 0, right? Now, when I tell you how to graph these, first thing I want you to do is, what is the period? Well, the easy way to figure this is you've got, what is the coefficient of your theta? No. What is the coefficient of theta? One. Okay. Coefficient is the number in front of the variable, so the coefficient of theta is 1. It's sine of 1 theta. So, a lot of times people will say this is in standard form if it's y equals a sine of b theta. Okay, so what is b? Well, what is b is 1. Okay, the period is either 360 over b or 2 pi over b. So if it's in degrees, it's 360 over b. If it's in radians, it's 2 pi over b, right? So here's how I graph it. Okay, so first find the period. So what is the period of this function?
360 over 1.
So 360. So mark that off. And then you divide it into 4s. So divide it in half, what would you get? 180. Divide that in half, what do you get? 90. So then that makes this 270. Now what I do is I call these quarter points. You see why I would call them quarter points? Because each one of them is a fourth of the period, right? Then the number in front is the amplitude. So this one is going to, instead of before the amplitude was 1. So here, all you got to do is make this 3 and this negative 3. And sine goes middle, top, middle, bottom, middle. That's the function. Make sense? This is for sine.
So, when we're doing this on homework, do we have to make a C-chart?
No.
So we can just...
You can go straight to this. But I'm just showing you where that came from. Because if you plotted all these little ones, it would
you
go on.
define it.
Yeah, and you don't need to. I wouldn't want you to do this because that's not what it looks like.
That's a different function.
Right. So it's got to be a sine curve, and we got that from the T-chart. You don't have to do the T-chart to know that, but once you know it, just you can find the quarter points and connect them with a curve.
So the amplitude is 3.
Yes. All right. Well, what happens if you have this?
Does that mean it'll be only?
So first, yes. So the period is 360 over 3, which is 120 degrees. So instead of making this 360, what do we make it? 120. Take half of it, 60. Take half of that, 30. Right? What's the amplitude? Amplitude's a distance, so it's 4. But the negative does come into play. Sine starts in the middle going up, but negative sign starts in the middle going down. So you go middle, bottom at -4, middle, top, middle. Makes your brain tingle. I like that.
Interesting. Because it's 120 and then you take half of 120 to 60 and then half of 60 which is 30.
I agree.
The amplitude is negative 4 or
Amplitude's a distance, so it's got to be 4. Now the negative just means that from the origin you're decreasing initially. Okay?
That's how you like plot it.
All right. So now let's look at cosine. So let's look at the parent function, just y equals cosine of x, or theta. What do you think the period's going to be? No.
Period.
Is it the same as time? 360 over B?
So it's 360 over b, so it's 360, right? So that means this is 180, that means this is 90, that means this is 270. What do you think the amplitude is?
It's
1. So we're going to go up 1, we're going to go down 1. However, what is what is cosine of 0? It's not 0. It's 1. What is cosine of 90? 0. What's cosine of 180? -1. Cosine of 270? 0. Cosine of 360 is the same as 0, is 1.
Oh,
So
it's
here's
like
what it looks like. Well, if I could draw. So it's just like a sine graph, except sine was started at the origin increasing. Cosine starts at its maximum and is decreasing. Okay? So what would happen here? What is the period?
2/3.
It is
360 divided by
360 divided by 2/3. Now that's not 2/3 of 360 because of means multiply.
3 over 2 times 360.
Right. So that would be 360 times 3 over 2, which is 180 times 3, which is 540. So this is 540. So what's this?
Yeah.
270. So what's this? 135, which means this is 305. Because each one of these has to be 135. Okay. Cosine starts at the top, so what's the amplitude of this function? 6. Okay. Now, one thing I don't want y'all to forget is I'm drawing each one of these with very different scales. Like here, okay, well, hold on. Let me finish this one and then I'll show you what I'm saying. So where does cosine start? At the top. And it goes top, middle, bottom, middle, top. Right? Now look at these two. They look almost identical the way I graphed them, right? But the scale is very different. This is 1, but here this is 6. So if I were to graph these on the same one, the other one would only like go up to here. Does that make sense? So realize that the scale is different. Most of your graphs are going to look the same, but if you were to put them all on the same graph, you would see that the ones with bigger amplitudes go up and down much more than the ones with small amplitudes.
Yeah.
The ones that have a long period are very different than the ones that have a short period. Does that make sense? See, this is 360 degrees. Well, that is here on this one. So this one would look more like that. But if you zoom in on them, they look identical. But the scale is different. Okay? All right, so just have that in your mind, because you may do all these and say, well, every single one I've graphed looks identical. But it's just because you're drawing it to very different scales. Okay? Just like if you graphed a line on a graph where x went over 1, y went over 1, and you graphed it on one where x went over 3,000 and y went up 2, they would look very different. But it could be the same. So just know that the scale's different. The only other one we've got with cosine is what happens when it's negative cosine. So what if you have this? Okay, so what's the period? 360 divided by 1/10, which is 360 times 10, which is 3,600. So see, this one is one that's way stretched out. It's 10 times wider than the ones we've been doing. But when we graph it, it's going to look identical because I'm going to zoom in, or zoom out, actually, from 0 to 3,600. Whereas if we drew it to that normal scale, we would be drawing 10 of these in the same place where we drew the other one. Okay? All right, so then that means this is 1,800, which means this is 900, and this is 2,700. What's the amplitude? 1/2. So we're going to go up 1/2 and down 1/2. Cosine starts at the top. Where do you think negative cosine starts? Bottom. Started from the bottom. There it is.
But it's only the beginning of the day.
Okay.
He clarified that when he did basically
The quarter points go, they cycle from bottom, middle, top, middle, bottom, middle, top, over and over. So sine starts in the middle. It's increasing if it's positive, it's decreasing if it's negative. Cosine starts at the top if it's positive, bottom if it's negative. And you always have to go through the middle. You can't go from bottom to top. You got to go bottom, middle, top, middle, bottom. Okay? All right. Now later, we're not going to do it today. We're going to learn what happens when you shift these right or left, or up or down.
Does this get any harder? Can you flip it?
Well, flipping them is the negative.
Yeah.
Oh, okay.
Yeah.
I see.
Now, there is one thing. So what if I ask you to do y equals 3 secant of 2x?
Okay, so secant.
Now, secant is the inverse of cosine. Or, I'm sorry, the reciprocal of cosine. The inverse of cosine is inverse cosine. So, but secant is the reciprocal. Now, reciprocal means 1 over, right? So let's think about this. Okay, so I wish I had a different color. Maybe you can see this blue. Okay. What if I graphed, can y'all tell that's a different color? Maybe. What if I graphed 3 cosine of 2x? Here, I'll do it in pen and it'll be lighter. Okay, so if I was doing that, what's the period? Divided by 2, so the period is 180, right? So that means this is 90, that means this is 45, that means this is 135. So I found all my quarter points. What's the amplitude? 3. Okay. Positive cosine, where does it start? The top. So it would go here, here, top, middle, bottom, middle, top, right? Oh, good. You can tell that's a lot lighter. Okay. So that's this, right? Well, this is the same thing except it's 1 over that. So what is 1 over 3? 1/3. Right? Then, right, like here it's 1, right? That would be like 1, right? So I guess 1/3 would actually be a little lower, but okay, let me make sure I'm saying this right. So here, this is 3. This would be 1 over 3, right? So it would be like down here, actually. Let's say like right here. If that's 1, this would be 1/3, right? Then here, where this function is 1, right? What would this function be? 1 over 1, it would also be 1, right? Now what about at 45? What's this function at 45? 0, right? This function at 45 is 0. What would this one be at 45 then? 1 over 0, undefined. So what you do is you graph the reciprocal function. If I wanted you to graph this, you graph the reciprocal function. Anywhere there's a 0, you make an asymptote. Okay? And then you go to the top and the bottom. Here it was 3, so its reciprocal is 1/3, right? Here it was -3, so what's its reciprocal? -1/3. Here it was +3, so what's its reciprocal? 1/3, right? And from that, you draw parabolas. Right. And it jumps to infinity. When you're dividing by 0, that jumps to infinity. And sure enough, if you found like 60 degrees, if you plug that in there, you'd get this value, like right here. 1 over that would be down here. Okay? Does that make sense? So what you do is you graph the other function. Where it has zeros, those become asymptotes. Where it has maximums, those become minimums. Where it had minimums, those become maximums.
Okay.
And this can never be 0, because 1 over something is never 0. You can't divide 1 by anything and get 0. So that means it can't cross the x-axis because it's never 0. Okay? All right, the only one that's different now is, hold on one second. Let me see what we've got here. Yep. And I'm posting this online so everybody can see it. Okay? The last one is tangent and cotangent. Okay? Now, tangent and cotangent are different because they only have a period of 180 instead of 360. Okay? Always. Well, unless there is a coefficient. Okay? So if you wanted to graph y equals tangent of x, what that looks like, now tangent is sine divided by cosine, right? So that can be undefined when cosine is 0, right? Cosine is 0 at 90, at 270, at 450, and so on, okay? So then this is 180, this is 360. So we know it's undefined here, so we need an asymptote. So if this repeats, there would also be an asymptote at -90, right? Tangent behaves like sine. Where does sine start? So think about this. What's on the top of tangent? It's sine divided by cosine, right? So since sine's on the top, it gets to call the shots. And sine says, I start at the origin and I go up, right? So tangent does the same thing, except it can't cross this line. So it can't do like sine does. Sine says, well, you got to start in the middle and go up, but tangent said, hey, I can't cross this line. So they compromise, and that's where it goes. Okay? That's what the graph of sine or tangent x looks like. Now, can we talk about the amplitude? No, because it goes forever. But it can have a number out here. And what that number is you find this quarter point. What would that quarter point be? 45, right? The y coordinate is this number. So if that were a 10, this would be stretched up and be a really steep tangent curve. All right? Now cotangent is really easy because it's just like this, except it starts in the middle and is decreasing. Now, what if you did negative tangent x? Actually, I lied. I'm so sorry. What I just graphed was negative tangent x. I'm so sorry. Okay? So sorry. Forget what I said 1 second before. Right. So it, hold on 1 second. Let me make sure that I'm saying this correctly. Okay, so here's the difference. Y equals tangent x looks like this. Negative tangent x flips on the y-axis, on the x-axis, right? So it looks the same. It's going down 1 instead of up 1 there. If you're doing cotangent, it is just shifted over until 0 is the asymptote, because cosine is now on top and sine is on the bottom. So when sine was 0, it's now undefined. You need roll. I just realized. I'm sorry. Everyone's here. Yeah. Everyone, yes, everyone's here. What now? Did what now? No. So, all right. So what cotangent is it looks just like tangent, instead of at tangent, the asymptotes are at 90 and negative 90. It's shifted over, the asymptotes are at 0 and 180. Right? And it wants to be different than tangent in every way, so it is decreasing. Well, so I'll show you. Here's what tangent looks like. So it shifts over and flips. Because cotangent is cosine over sine. So they're going to have asymptotes when sine is 0, because you can't divide by 0. And sine is 0 at 0, 180, 360, and so on. Okay? All right. Your homework is a worksheet and, sorry. Yes. Yeah, I'll get it to you by the end of the day. Right. Yes. Okay. Actually, let's just start with the worksheet. Your homework is 14.1 worksheet. Okay.
Why would not you want to be recorded?
Yes, I will record.